We open SDM4 Chapter 7 Linear Regression with a mouth-watering picture of a veggie burger. This is taken from Burger King, where we have kind of relationships between protein and fat in a scatter plot. So kind of building on what we saw previously, but now adding this idea of the least squares, the line of best fit. And it's a very useful figure here, 7.2, thinking about the meaning of the residual there, and the idea that the residual is the observed minus the expected or predicted value. The linear model is defined more formally on the next page in section 7.2. Where the book here describes B1, I will typically call it beta 1, the Greek letter, to indicate that it's a population parameter, not a sample statistic. We'll talk more about that, but we can actually see how things are related in terms of those values of those parameters. Nice example from the hurricanes data. The relationship between the slope and the correlation and the standard deviation is a useful relationship. Just to give you kind of a sense, the correlation is a unitless measure. The slope is actually in the units of the actual data. So we can actually go ahead and find this in terms of those values in a straightforward fashion. But again, this idea of the regression line is the big part here. There's another example here where things are calculated in terms of a bridge collapse and bridge safety from New York State. Useful working through that. Section 7.4 talks about an important concept called regression to the mean. And this idea of how the regression can be used or sometimes misused is really going to be important for us. The just checking, six very useful assessments for you as you're working through the reading. Again, just as a reminder, I would be encouraging you to work some practice problems, odd number problems in the back of the book for all of these sections as you kind of proceed through. There is a math box here which describes a little bit about where the calculations are coming from and how things are structured. It's kind of interesting if you're interested in math, if you're a math major, this would be very valuable to look at. We're not going to be focusing as much on that. However, we will be spending a lot of time and energy examining the residuals and really thinking about model diagnostics. How well does our model fit, and what observations do not fit particularly well? So we can calculate those residuals. We can calculate something called the residual standard deviation. And what's different about this is a slightly different formula for the standard error. It's pretty much the same as what we've been seeing before, but with an n-2. And we'll talk about what that is, the reason for that difference. One assessment of the model, not a be-all and end-all, but a useful one, is R squared. It's the proportion of variance accounted for by the model. That's the topic of section 7.6. And again, it depends on, there's not really a kind of particular threshold for where this is most useful, where things are kind of a good fit or not. And the idea we can be flipping things around is not going to give us exactly the same story. You really want to be thinking about what is predictive of what. Now, assumption and conditions are important for all of statistics. It doesn't make sense to be calculating something when the underlying assumptions and conditions don't hold. And here we're thinking about the quantitative variables condition, the straight enough condition, does the plot thicken, and also the outlier condition. So these are really good things to kind of be thinking about, and the step-by-step example on this page kind of works through the assessment of those in turn. And finally, kind of this idea of, is the regression reasonable? Ask a silly question, get a silly answer. We always need to be starting off with that. We close with one more example, some ideas of what can go wrong, and the learning objectives and review of terms. So multiple regression is going to be building from this in future chapters. It really requires kind of a good understanding of linear regression. How to do this in R? Again, fairly straightforward. We can read in the Burger King data. In this case, we can generate the scatter plot just like we did in the previous chapter. But now we can actually be thinking about fitting a model that we have on the top of page 2 here using the LM function. An additional thing that's made available to us through the Mosaic package is the makeFun function, which allows us to operate on a linear model object, in this case BK mod, and query it, for example, to calculate predicted values or to generate some plots. So here we can see BK fun with the value 31 is getting the predicted value for an item with 31 grams protein. We kind of step through different calculations. We can verify the calculation of R squared as we proceed, and we can generate the residuals. So here, by generating the residuals, we're saying a scatter plot of the residuals of BK mod. This is a helper function that operates on a linear model object as a function of protein. And M summary is a way of getting a concise summary, mosaic summary or model summary of this, where we can actually see the estimated intercept of 8.4 and the protein value of 0.9. Again, this is straightforward to be using in R, and glad to kind of provide this introduction to you for this chapter of SDM4.